So I'm going to talk to you about the change of base formula for dealing with situations where you've got logarithms written in more than one base. So let's suppose that you've got a number, we'll call it y, and that's written as a logarithm in base a. What I want to do is I want to introduce a different base, log base b. How am I going to do that? Well, by definition, what is log? It's a to the y equals x. That's what logarithm means. And once I've got that expression, I can introduce my logs to taking logs of base b of both sides. So take log base b of a to the y is equal to log base b of x. We had a look earlier at our log laws. In particular, we're going to use this one, that log of x to the power n, you can bring the power down. That becomes n log x. Those two things are identical. So log of a to the y becomes y log base b of a. Obviously that's still log base b of x. And then rearrange for y, we get y is equal to log base b of x over log base b of a. And the number that we started with, y, we had defined in terms of logs. Log base a of x. So this formula, which you will find in your formula booklets, is the change of base formula for introducing or turning one log into the base of another. And when it's useful is if you've got logarithms written in different bases to start off with. So there it is again. And all we're going to try to do is to take this expression and write as a single log. So if you want to have a go at doing that using the formula before I go any further, I give you a little hint, which is that it's going to be easiest to rewrite everything as log base 5. You can see there's some relationship between the bases, not being picked at random. 25, 5, a 10 here, and a 5 here. And also, since two of them are already in base 5, it makes sense to pick base 5. That's the one we want to turn everything into. So this bit and this bit are not going to change. Everything else I'm going to turn into base 5. So log base 25 of 9. Well, using the change of base formula, you always end up with one log over another log. And those logs are both the base that we're trying to change into. It's got log base 5 on top, log base 5 on the bottom. What goes here on the top? Well, it's just whatever I was taking logs of before, so in this case it's 9. And what goes in the bottom is whatever we had as our base before. So that's log base 5 of 9 over log base 5 of 25. This one doesn't need to change because that's already base 5. This one, same idea. Using the change of base formula, we get log over log, and they're both going to be log base 5. On the top, it's going to be log base 5 of 2, and on the bottom, it's going to be log base 5 of 10. And this one, log base 5 of 100. And now we're going to try and use some of our log laws, some of what we know about logs, to simplify this a bit further. So, first thing you might notice is that we can evaluate log base 5 of 25. That's what power of 5 gives you 25? Well, that's 2. So this is going to become log base 5 of 9 over 2. Or a half of log base 5 of 9. This one, there's not much I can do with that. Log base 5 of 7. But here, you should spot that there's obviously a relationship between 10 and 100. So what I'm going to do is I'm going to rewrite that. This is going to stay the same. That's 5 of 10. But I'm going to rewrite this logarithm as log base 5 of 10 squared. And we know from our log law that that 2 can go there instead. And that means that these logs, log base 10s, are going to cancel. So, next line is I've got a half of log 5 base 5 9 plus log base 5 of 7 plus these cancel, and we're just left with 2 log base 5 of 2. So that's already a lot simpler than the thing we started with. Now, the last couple of times we've used our log law for bringing powers down, but now I want to put everything back into a single log. I'm going to do the opposite, and I'm going to take these powers up. So that becomes log of 9 to the half. And that becomes log of 2 squared. Evaluating those, we get 3, 7 and 4, and then we can use our other log law that says when you add logs you can just multiply what's inside them, so that will become 3 times 7 times 4, and now it's written as a single log. 3 7s are 21 times 4 is 84. So we've gone from something that looks quite horrible, log base 25 of 9 plus log base 5 of 7 plus log base 2 of 10 of 2 times log base 5 of 100, to something that's actually much easier to calculate. And if I wanted to, I could tap that into my calculator and get it as a decimal, log base 5 of 84. Okay, oops, that's just my first go at that. Hopefully this is straightforward. Probably be a good idea for you to have a look at one of the examples before you come to class. So the example in your textbook is log base 5 of 3 times log base 3 of 5. Actually, they've written it the other way around. Doesn't matter, obviously. Log base 5 of 3 and log base 3 of 5. In the textbook, they give a fairly straightforward proof that that's 1 by turning everything into log base 3. What I think you should try to do is do the same proof, show that this is 1 by turning all the logs into log base 5. So in the book they've done it by turning everything into 3s. You can prove the same thing by turning everything into 5s. And obviously you've got a model there. Best of luck. I'll see you tomorrow.